So a digital twin is a virtual replica of an asset of any sort, not necessarily a building, which behaves like the real counterpart. So it's a virtual model somehow that can be used to simulate different scenarios. In the case of the building, it can be used to simulate different scenarios for operations of the building, for renovation, for retrofitting, and it allows the building to be more efficient by testing the interventions before to be implemented, so that it can act as a sort of de-risking investment supporting tool.
Building digital twin is meant for a tool for product lifecycle management. This is how it was devised for. At the end, this is providing the advantage of linking all the stakeholders, all the information that all the stakeholders should be using for making the right decisions across the whole building life cycle. Okay, so at the end, all the advantages that we can get from getting during the whole life cycle of any connected system, as it could be a smart building, across the lifetime to get the better decisions. It could be too many to be able to set a list, but it's true that it's a change of paradigm.
So I would say the market is becoming a bit more aware now about the, let's say, the potential of digital twins, but they are still now perceived as a static thing, like a BIM model, while there is much more ongoing, which is like making them not static anymore, but let's say operational, so behaving like the real counterpart. And the big challenge now is show people the value of using digital twins for let's say for improving their building operation, and also to collect the right data from the site that can help creating these operational digital twins of the buildings.
Interoperability is the main concern. Okay, at the end, right now we have a lot of data, but it's siloed. Okay, what it means that people is not able to share the data. So at the end, how we could be able to transfer the data and to be able to give the real data that people needs, okay, the representative data that people needs to take the right decisions, okay, is key. And it has only, and this is related not only with the technology, this is also related with processes. And on this regard, for me, that's the second big issue with the implementation of digital twins, which is how we get the right processes in construction industry to get, or even in real estate, okay, also in manufacturing and operation, to get the models of information inside of the building digital twins environments to keep in track of how the asset is evolving.
Digital twins can be used at single building level or at community scale. A very typical application could be a decarbonization project in which, for example, take a university campus as the goal to decarbonize by 2045, for example, and they want to understand how they could do that. So they use a digital twin at the campus scale first to understand like what are the buildings that are like performing worst through dynamic simulations, and then once they have identified these buildings, they can go and do a detailed digital twin of the single buildings level. They can run calibration, making sure that it behaves like the real counterpart, and then use it to test different strategies, for example, changing set points of the HVAC system, or like testing renovation strategies for reducing the building energy demand. And then you can go back to the scale, campus scale, to look at how the buildings interact one to each other. Again, on a digital twin, but looking at supply and demand between different buildings to make sure that you can drive the campus towards net zero.
We at IDP, we are the coordinators of the Sphere project, which was the first European project talking about building digital twins. But moreover, in terms of private implementation, we had in the last 2-3 years, we have raised contracts by worth of 2-3 millions, okay, in consultancy in developing digital twins. It could be referred from public buildings to industrial buildings, like might be factories, parking lots, even civil infrastructures like might be a port infrastructure, or even linear infrastructures like might be railways. So at the end, the applications are many, the examples are many, but it's true, and this is something that I'm always try to stress out to my fellow colleagues in the engineering company, that we are at the beginning of that. Okay, so we need the processes. The technology is almost there. There are a lot of technologies that we can use. Other thing is that we will have a cost-effective technology. But at the end, how we can get the standardized processes, okay, to get all this tracking to how the asset is evolving, okay? Also how the hierarchy in between different digital twins, like might be the cities, like it might be the appliances, or even the persons inside of the building, how they are connecting with the digital twin of the building, how we are able to connect all this information is key, okay? And the processes are an inherent big part of that.